Hi, welcome back to another episode of Algebra in Words, the video series. In this video, we're going to continue our discussion on compound inequalities. In the last two videos, I gave an overview of compound inequalities, and we solved a few compound inequalities. In the ones in the previous video, we started off with two simple inequalities that were sort of already ready to go, but in this video, we're going to start with two simple inequalities, or this is compound because it's connected with or, but we're going to have to do a little solving in the beginning. And it's not that much, it's just one or two steps. So let's take a look and notice how we have this inequality, 5 minus x is greater than 1. Then we have or, which is significant, and we have x plus 3 is greater than or equal to negative 1. Let's start with this portion on the left. And notice that it's not solved or simplified yet. So we're just going to solve it, and that means just getting x alone. So to do that, notice that we have a 5 on the left. Let's subtract 5 from both sides. And then that's going to give us negative x is greater than, and 1 minus 5 is negative 4. Okay, now we have a very crucial point that we need to pay attention to, which is to get x alone, meaning positive x, we have to divide both sides by negative 1. And this exhibits the principle that when you divide both sides of an inequality by a negative number, you have to change the direction of the inequality symbol in the middle. So let's show divide both sides by negative 1. And negative x over negative 1 is x. And now we're going to reverse the symbol from greater than to less than. And negative 4 over negative 1 becomes positive 4. So now we solved our first simple inequality into the simplified form. And now let's do the same for the other one on the right. Minus 3, minus 3. We do not need to alter the symbol in between because we did not multiply or divide both sides by negative 1. But we subtracted, and negative 1 minus 3 is negative 4. So we get x is greater than or equal to negative 4. Okay, now we're going to graph this, and then we're going to report the answer in interval notation, as well as I would like to give it in consolidated inequality form, but you'll see what happens. So I know how it's going to end, but let's see how it plays out. So first, let's graph. We're going to draw a number line, and it doesn't matter which one you start with, we're going to put them both on the same graph. Let's start with the one on the left, just randomly choosing. Okay, and since 4 is higher than negative 4, just put the 4 closer to the right side, like this. And since its x is less than 4, and it's a non-inclusive symbol, we're going to draw that with a parenthesis open to the left. And now we're going to plot the negative 4, and that is an inclusive symbol where x is greater than negative 4, so we're going to show that by an open bracket, open to the right. Okay, now, even though you don't have to do what I'm going to do this just for exhibition purposes, but I'm just going to show on the graph, using a red mark and arrows, the values for each simple inequality. So if we're looking at this one, it would be from non-inclusive 4 and all values less than 4. And if we're looking at the negative 4 and inclusive all values of 4 and greater, it would go in this direction, right? Now, this is where the word and or plays a crucial role. Remember that this is or, and or means the union of. So that means all the possible values that are contributed by either or all of the simple inequalities from the statement or ultimately graphed. And if you notice, The red line that represents that and its arrows cover all values. So long story short, there's two ways that we can write the answer. If we write it in interval notation, one way we could write it is this. Negative infinity with a parenthesis, comma, positive infinity with a parenthesis. But if we were to write it in, say, a consolidated form, what I'm trying to say is you can also write all real numbers. And that's a satisfactory way to report the answer in a case like this where all the possible values of x using or union would be all the possible numbers from negative infinity to positive infinity. I'm going to pause the video and then I'm going to put up a three-part compound inequality and show you how to solve those. So what is a three-part compound inequality? Well, actually, we've already looked at them. It's just that I was calling them by a different name. I think of okay, so first of all, what is a three-part inequality? It's where you have a part here, a part in the middle, and a part on the right. But more specifically, okay, once we solve this or simplify this, the x should be and always will be in the middle portion, and numbers on the left or right. This is just not in simplified form yet, but the goal to get it into solved or simplified form is to get the value of the variable, or x, alone in the middle. So, what I was saying before is, or at least myself, I think of this as a consolidated inequality because it's made up of two simple inequalities, this portion and this portion. But when they're combined as one way to call them is a three-part inequality. And a three-part inequality can come unsimplified, which is what we see here. And the method to solve or simplify a three-part inequality is easy. And I'm going to explain what to do right now. All you have to do is I want to compare this to solving a simple inequality or even an equation. And if you remember, the rule is what you do to the left side, you have to do the same thing to the right side. The same follows here, except what you do to the middle, you do to the left side and to the right side. So let's look at this and think, how do we get x minus 7 into being just x alone? And the answer is, we can add 7. If we add 7 here, the negative 7 plus 7 cancels to 0, leaving just x. But remember, what you do to the middle, you do to the left, and you do to the right side as well. So let's do that. We added 7 here, let's add 7 here, and let's add 7 here. And then we're just going to write what's left. On the left, 5 plus 7 is 12. Keep the symbol less than. X stays x. And the 7's cancel to 0. Rewrite the other less than symbol. And 10 plus 7 is 17. So the answer in simplified or solved form for the three-parter is 12 is less than x is less than 17. And before you circle it or move on from the problem, just sort of read through it to make sure that it makes sense. If it doesn't, you might need to do a rearrangement, but in this case it does make sense because 12 is smaller than 17, so the arrangement of that is correct. But we can also report this in interval notation, so let's do that as well. And we could graph it if we wanted, but let's jump right to interval notation this time. So we'll start with the lower limit number, which is 12. And now, will it be a parenthesis or a bracket? To answer that, look to its associated symbol. And it's non-inclusive. So that tells us it's going to be a parenthesis, which has to be open to the right because the 12 is the smaller number. and which makes sense because the values of this would be x is greater than 12, which would mean values towards infinity. Comma, and now the 17. And again, is it going to be a parenthesis or a bracket? We look to its related inequality symbol, and it's not inclusive, so that tells us a parenthesis. So to summarize, for a three-part inequality, it has a left portion, a middle portion, and a right portion. And you can think of it as a consolidated statement of two simple inequalities put together in proper form. We wanted to isolate x, and to do that, we added 7 to both the middle, the left, and the right to maintain the inequality. And it only took one step to simplify down to this, which then we converted into interval notation, and we're done. It could also be graphed, and just for the sake of it, let's graph it. And it would look like that. Okay, I have one more on the board on the right side, and you're going to notice one extra little nuance to this, which is why I strategically put it on the board. So let's get started. Again, this is a three-part compound inequality. The goal is to get the variable in the middle alone. And so far, it's not the variable alone, it's negative 4x, but we need it to be x. So how do we convert negative 4x to get x? Divide that by negative 4. And when solving a three-part inequality, what you do to the middle, you do the same to the left and the right. So we're going to divide the left and the right by negative 4. But there's one other thing you have to remember, which I've been trying to repeat throughout this and the last two videos. This is a good example. If you multiply or divide both sides of an inequality by a negative number, which now the negative 4 is, you have to reverse or change the direction of the inequality symbols. So negative 16 divided by negative 4 is positive 4. But now we have to reverse this symbol from less than or equal to greater than or equal to. Negative 4 over negative 4 cancels to 1, leaving x, which is what we want. And then we have 8 divided by negative 4, which is going to equal negative 2. And again, because we divided by a negative number, we have to reverse the inequality symbol from less than or equal to greater than or equal to. Now before we end there, and we will graph it, but before we circle the answer or move on, we want to read through the statement to see if it makes sense. It does make sense, but the convention that we want is for the lower number to always be on the left, so when you read from left to right, it goes from lower to higher. So all we're going to do is take this entire three-part consolidated inequality and flip it so the negative 2 is on the left, and when we flip it, we have to flip the symbols as well. So this was greater than or equal to, and it's going to be back to less than or equal to. The x stays in the middle. This is flipped from greater than or equal to less than or equal to. And the 4 goes on the right now. And now it's in its best convention with the lower number on the left and the higher number on the right. Just to clarify, the flipping from here to here and here to here had nothing to do in that step with multiplying or dividing by a negative. It's just a matter of flipping sides. And when you flip sides, you have to move the whole thing, kind of like as if you're doing it with a mirror. But, again, to summarize here, it's to reinforce the fact that when you multiply or divide both sides of an inequality by a negative number, you must reverse the inequality symbol. Before we end this video, now that we have this, let's write it in interval notation. These are both inclusive symbols, so we're going to put the lower number on the left with a bracket open to the right, comma, the higher number, and then a bracket open to the left. And that's our answer in interval notation. And before we end, let's also graph. Draw the number line, the lower number sort of on the left side, which would be -2, and the bracket open to the right, and then the 4 on the right side with a bracket open to the left. So that concludes this video on solving complex inequalities and three-part complex inequalities. So thanks for watching, and see you in the next video.